Hi, I want to discuss about a common problem that when you are searching to buy new batteries from eBay, you can never know which batteries are the best and if all the information is correct and if you can trust the seller or whatever. So I have a project on my mind for a long time that I will be able to measure the battery capacity and not trust the sellers that I'm buying from. So let's see an example. If I choose to buy LR44 batteries, so is it okay to buy this Maxell or maybe to buy, I don't know, a Suncom, or maybe to buy Duracell or GP, or if I'm buying the GP or the Duracell, is it a fake one or it is the original, or how can I know what to do? Same problem if I'm going to lithium battery, which is 18650. If I'm buying these batteries, so I can see here batteries capacity of 90,900 milliampere hour Leon. Of course, this is bullshit. No battery in this side can hold this capacity. Again, another bullshit. And if I'm going to Panasonic, this number can be a real number. And how do I know this? Because I've already done many tests with these batteries. Ultrafire 5000 milliampere per hour. This is again absolutely bullshit. Trust me, it can't be this capacity at this size of battery. Unless maybe I don't know what they're trying to do, but it is not reasonable. Maybe it is like atomic battery. Of course it is not. Okay, so on my mind I want to design using this Arduino Uno and this LCD display. I want to design a circuit that will actually measure the capacity of the battery. So before doing such a project, I need to look at the datasheet and try to investigate and see what I can find out. Okay, so let's see if I'm going for the LR44 battery. So let's open the datasheet and see what we have. So in the specification I can see, of course, the voltage of the battery, the minimum on-load voltage, which means that if I connect to this battery a resistor of 50 ohms, the voltage will drop maximum to 1.42 volts. But I really don't mind about this information. What is most important to me as a battery user, with all the toys for the children, is to know if the rated capacity, which is 105 milliampere per hour, is a true number or a bullshit number that is supplied by the seller. So if I'm going to the discharge curve, I can see that they have to put some information how they are rating the capacity. Example, they are saying here that the capacity is 105 milliampere, but this is only the case if you will put a load of 6.8 kilo ohm and you will measure till it is dropping to voltage of 0.8 volt, which means that how the manufacturer is determine all the information. Every manufacturer can put other information, because this voltage is not fixed, and maybe other manufacturer will measure if it is going to a lower voltage. Okay, so what I can see here in this typical discharge characteristics, that I can discharge the battery. Here they are doing tests with two different resistors, 470 ohm, which of course will discharge much faster the battery, and 1K. The curve is more like the same, let's say. Of course, 1 kilo ohm is more than twice for this resistor, so the time is almost twice the time. So if we are about I don't know 45 hours on the x-axis, so when I'm discharging with 1 kilo ohm, so the time is twice. Also I can see the number of the discharge current, which by the way is not very accurate, or because for sure the current here is much lower and the current here is much higher. So they're giving me the information that the current is at this voltage, which is 1.25 volts, which means that if I will look at the curve, it is something here. This is the current in this, and they assume that the current is fixed all the way down to here, which is a very good approximate. Why is this? Because if you will take this button, this point and this point, and we will draw a straight line between these points, so it is going somewhere in the 1.20, not exactly, but it is close to the point, and this is, let's say, linear, and I don't want to calculate integrals, and I want to do a much faster way to measure the current. Okay, so by the way, the current is measured by milliamps per hour. Okay, so what I can do here is take this number and multiply it by the hours, and then I will get the total capacity milliampere per hour. For example, let's take this number, 2.7 multiply with about 45, and let's see what we will get in the capacity. So it will be 2.7 multiply by about 45. So this is 121 milliampere, which is more than rated. Now let's take the curve here, which is about, I don't know, maybe 95, and try to see what we will get here. Okay, so let's do it. 1.25 multiply with 95, and we get, yes, we get something like 118 milliampere per hour. Okay, so I need to build a circuit with the resistors that will be fixed in my case, and then I will use a RTC, real-time clock, and start measuring the voltage on the battery while discharging it. So I will look at the curves and When I will put it into the Arduino ADC, I will measure it, let's say, every 1 second, and I will see the voltage is dropping, and till it will drop to 0.8 volt, and then I will stop, and I will have my start time and end time. I will calculate the difference between the end minus the start time and multiply this number with the current of let's say I will take same point 1.25 volts divided by 470. So actually this number multiplied by the time difference, and then I will get the actual capacity. I will do this circuit, write the software, and with the LCD I will be able to see the actual battery capacity. Okay, now about the lithium battery. So let's see the lithium battery. Okay, so in this Panasonic, for example, I have a capacity which is minimum and typical, and then I can see discharge curves. Okay, I can see the discharge curve, characteristic, biorate. Okay, and the discharge depends what is the discharge capacity. By the way, 1C is one capacity of the battery, which means that I discharge it at current of I guess typical 2019 milliampere per hour. So I need to calculate my resistor, and if I take in the 2C, which is the maximum discharge, so it will be twice this current, so of course the resistor will be half then the typical resistor, and I will have to do the same, and here the cutoff is 2.5 volts, because if I'm discharging more than this voltage I may harm the lithium battery, and it will be out of order. So I need somehow, if I want to protect my cells, to switch off the discharge when I get to the 2.5 volts. By the way, here are the charge characteristics, and basically lithium we are charging with constant current and then constant voltage. This is the CC and CV, which means constant current, constant voltage, and this is the limit for the maximum charging current, which is 0.7C, which is 0.7 of the typical number here, which means that I don't want to charge this battery faster, because again I may harm and break it. So let's see the number just to know what we're talking about. Okay, so we need to multiply this in 2900. Okay, so this is the maximum charge current, which is approximately 2 amps, 2 ampere. Okay, so this is a little about batteries. Most of the batteries I've seen on eBay are fake, and usually the Panasonic are not fake. what I have measured, and it will be nice to build this discharge tester. Okay, so in order to test correct the lithium battery, we will first need to fully charge it, of course, and just after fully charging it, to connect it to our discharge circuit, and again count the time till we get this voltage, and then by doing the multiply the time with the current, we will be able to see the real capacity of the battery. Okay, so this is all for now about batteries, and thank you for now.